In today's topic, we're going to be talking about the equations of linear motion. Linear motion. Okay, so before we start discussing the equations, you need to know a few things. First, velocity is displacement divided by time. Acceleration equals to the change in velocity divided by time, which is just the final velocity minus the initial velocity divided by t. So knowing these formulas, we can now start discussing the equations of motion. Our first equation is v equals to u plus at. Now what is v over? V is the final velocity, u is the initial velocity, a is acceleration, and t is time. So now I'm going to tell you how we derive this equation. So as I told you, acceleration equals to v minus u by t. So if we transpose t here, we have at equals to v minus u. If we take v here and at here, we'll get negative v equals to negative u minus at. So therefore, if you change all signs to positive, or you flip all the signs, basically we'll get the equation v equals to u plus at. That's how you derive the first equation. The final velocity equals to the initial velocity plus acceleration into time. You may also call this equation v equals to v0 plus at, v0 being the initial velocity. All right, our next equation is distance equals to ut plus half at square. So distance equal to the initial velocity multiplied by time plus the plus half into acceleration times time t square, which is time square. How do you derive this equation? So we know that distance equal to average velocity over time, sorry, into time. So average velocity is just the initial velocity plus the final velocity, or both of the velocities, over 2 multiplied by time. Alright, so in our first equation we knew that v equals to u plus at. So over here we can sub in the v for u plus at. So therefore s would be equal to u plus at over 2 into t. So s equals to u plus at is 2u plus at over 2 into t. So 2 will get cut for you, and then when you multiply t with u, you get ut, and then you have plus 80 into t is 80 square over 2, which you can rewrite as s equals to ut plus half 80 square. And that's how you derive this equation. Over here we can also write this equation as s equals to It could be any. This v0 being initial velocity again. Oh wait, yeah, okay. And our last equation of motion is v square equals to u square plus 2as. Okay, so again we know that we know that distance equal to average velocity into time, or velocity into time, whatever. So the formula for average velocity is v plus u over 2 multiplied by t. Alright, from our equation v equals to u plus at, when we find out the value of t, we get v minus u by a. So t is v minus u by a. So when you sub that in over here, s would be equal to v plus u over 2 times v minus u over 2. So what do we have here? A plus. So if we take a plus b times a minus b, the algebraic property, a plus b times a minus b equal to a square minus b square. For the top, or for the numerator of these fractions, we'll get on top v square minus u square, v being a and u being b, divided by oh wait, I wrote 2 here, this should be a. That's my bad. Yeah, so this over 2a. When you transpose 2a here, we'll get 2as equal to v square minus u square. And using some algebraic properties, we get the final answer v square equals to u square plus 2as. Sorry, final equation. And that's how you derive a third equation. So the formulas you should know to derive these equations is: first, acceleration equals to v minus u by t. Okay, distance equals to v plus u by 2. Alright, time equals to v minus u by a. Velocity equals to distance over time. Alright, and yeah, oh, this is just average velocity into time. So we'll have this times t. That's my bad. These formulas you should know for the derivation of these equations. Alright, let's solve some questions using these equations. Okay, a car acquires a velocity of 72 kilometer per hour in 10 seconds from the starting point, or 10 seconds from rest. Yeah. All right, calculate first the acceleration, then calculate the average velocity, and then calculate the distance traveled in this time. The distance traveled. All right. So first, since we have the units 72 kilometers per hour, we need to convert this to meter per second. So we can just multiply by 5 over 18, right? And 18 times 4 equals to 72. So 18 ones are 18 fours are. This equals to 20 meter per second. Oh, and this is a shortcut. So to convert meter per second to kilometer per hour, you can multiply by 18 over 5. But to convert from kilometer per hour to meter per second, you can multiply by 5 over 18. That's what I did over here. So we get our final velocity as 20 meter per second. So first we have to calculate the acceleration. So acceleration equals to v minus u by t. So our initial velocity equal to 0 as the car started from rest, as it's stated in the question. So and our final velocity is 20. So 20 minus 0 divided by the time, which is 10 seconds, equals to 2. So the acceleration is 2 meter per second square. Next we have to find the average velocity. So average velocity equals to v plus u by 2 basically, and this would be equal to 20 plus 0 by 2, which equals to 10. So the average velocity is 10 meter per second. And third, the distance traveled, basically s, is equal to average velocity into time. Average velocity we just got as 10, and time is 10. So the distance is 100 meter. And these are the three answers. Alright. Moving on. Our next question. A body moving with a uniform acceleration travels 84 meter in the first 6 seconds. You should write these questions down while pausing the video. In the first 6 seconds, and 180 meter in the next 5 seconds. Alright, find the initial velocity and the acceleration. Okay, so we'll say let u be the initial velocity, so given distance 1, which we can say s1, equals to 84 meter, and time 1 is 6 seconds, which was taken to cover this 84 meter. So and s2 equals to 84 plus 180, which equals to 264 meter. So the total distance, and time 2 will say equal to 6 seconds plus 5 seconds, which equal to 11 seconds, which is the total time and the total distance. So from relation, or from the equation, s equals to ut plus half at square. Alright, so to find the distance traveled in 6 seconds, what would we do? So 84 equal to u times 6. No, sorry, not to find the distance. When you plug in the values in this equation, what would happen? Half a times 6 squared. Two ones are two threes are. Therefore 84 equal to 3u times 36a. Therefore, oh no, wait. Let's just say 6u. So we won't cut this. 6u plus 18a. So I cut these two. Equal to 84. So, or we can say u plus 3a equal to 14 when you simplify this. So the distance in 11 seconds, this was for distance traveled in 6 seconds. Now we'll put this in for 11 seconds. So 264 equals to u times 11 plus 1 over 2 a times 11 squared. Alright, so on solving this we'll get 11u plus 121 over 2a equal to 264. And let me simplify this. U plus 11 over 2a equal to 24, which is what you get when you simplify. So on solving both of our equations, the initial velocity would be equal to 2 meter per second and acceleration would be equal to 4 meter per second square. That's the answer. I didn't do much of this. I didn't do this question in detail so that you guys can solve it on your own. And okay, our next question is a car initially at rest starts moving with a constant acceleration of say 0.5 meter per second square and travels a distance of 25 meter. Alright, find its final velocity and the time taken. Okay, you can read the question. Once a car initially at rest starts moving with a constant acceleration of 0.5 meter per second square and travels a distance of 25 meter, find the final velocity and the time taken. So a trick is that in every question a minimum of three variables, or no, not variables, a minimum of three things would be given for you to solve the question. So over here a car initially starts at rest. So if they've given us u as 0 meter per second, what else have they given us? They've given us an acceleration of 0.5 and they've given us the distance which is 25. They will always give three things for you to solve the question. Alright, so from the equation of motion v square equals to u square plus 2as, we can plug in the values, right? So v square, which is final velocity squared, equals to 0 squared plus 2 times zero point 0.5 times 25, right? So therefore v squared equals to 2 times zero point 0.5 times 25 is just 25, right? And therefore, because 2 times zero point 0.5 is 1, so v would be equal to root 25, which equal to 5. So our final velocity is 5 meter per second, and then we have to find the time taken. So t is equals to v minus u by a, alright, which equals to 5 minus 0 by a, which is 0.5. Alright, so this equal to 5 divided by 0.5, which equal to 10. Oh sorry, 10 seconds. And that's the answer.